Hello everybody. So we are going to compute IDFT of the sequence using matrix method. Now the formula of IDFT is just like DFT. What is the requirement in the left hand side here? We should able to find xn bar that will be the, as per formula, it will be equal to 1 upon n w n conjugate. What Wn we have calculated in the DFT, it will be conjugate of that, and it will be again multiplied with a matrix of x4 given, xk, x capital xk. Okay, so now what is the beauty of this type of transformation is that it becomes something very easy. Suppose you have a 4-point DFT. As we have calculated in the previous example of the linearized method, you know a 4-point DFT will always the same. W4 for a 4-point DFT will be always the same. W8 for a 8-point DFT will always the same. W16 for a 16-point DFT will always the same. That means if you know the what is the sequence on the DFT, you have just only, you can write the matrix, or you at least memorize a bit that the matrix will look like this. So it will be obvious in the exam that you will able to, you know the problem is what you are doing is right, and what you have to do, you just put the matrix and multiply to get xn. Or similarly, what you have to do, if you know the matrix, you just make it conjugate. That means where the j are present, make it minus j, or where the minus j's are present, make it plus j. Otherwise, all the matrix will be same. And in this way, in a very short time, you will able to compute the IDFT. So my suggestion is, we have done the DFT as well as IDFT using formula. We know it is, we have to calculate it so many sequences. That means for n number of DFT, we have to, for each and every point, suppose for x0, we have to add n number of, n minus 1 number of points. So for n number of DFT, total number of addition will be n into n minus 1. Okay, so there are n number of multiplication. That means if it's a 4-point DFT, 4 multiplication e to the power, that multiplication is present. So how many number of multiplication, total multiplication is present in n-point DFT, it is n square. So that means you have to, for a 4-point DFT, you have to go for a 16 number of multiplication, as well as 4 into 3, 12 additions. So that will take time. So, if it is not mentioned in your exam or in any time, you can use this in a much lesser time. So, now just calculate this one. So, we know that for a 4-point DFT, the value of W4 we have calculated in the previous example, it is becoming 1, 1, 1, 1 and 1 minus of j minus of 1 plus j. Similarly, 1 minus of 1 plus of 1 and minus of 1. And the last row was 1 j minus 1. Sorry. So it will be minus 1 and then it will be minus of j. So from here what we have to calculate, if this is W4, so what will be W4 star? W4 star will be 1, 1, 1, 1, 1, 1, 1. This j will be plus j, minus 1 remains same, this j will be minus j. Again this one minus 1, this one plus 1, this one minus 1. Here also it will be minus j, this will be minus 1 and it will be plus j. So this will be our W star. And from W star, what we are going to calculate? We are going to calculate x of n4. The formula is 1 by 4 into this whole matrix and the given xk, that is 4, 1 minus j minus 2 and 1 plus j. So if you put this matrix and multiply the whole thing, you will get the final answer as 1, 2, 0 and 1. Please compute. So this will be your final answer. Okay. So this is, what is this? This is basically your xn. So xn will be 1, 2, 0 and 1. Thank you.